Hello and welcome to Fresh Thinking by Snowden Optiro. We're going to have a series of three podcasts here on sampling, more or less. And I'm very pleased to introduce our special guest, Mark Murphy. Mark is, most people know Mark, but he's the manager of Geological Services at IGO. He's also worked in operations for Anaconda Nickel and Rio Tinto. And he also worked extensively consulting for Extract, AMEC, and even for Snowden at some time in the past. So welcome, Mark.
Yeah.
So this first podcast, we're going to talk about why sampling is important for geologists. Mark, those of you that follow Mark, and many people do, will know that he's very passionate about sampling. So we're going to explore some of those perspectives in this podcast. So the first question, Mark, is, it may seem obvious to you and I, but why do we need to understand, as a geologist, why do we need to understand sampling, and why is sampling important, theory and practice?
Very good question. Yes. So actually, I was pondering this last night before I came onto this podcast, and I'm kind of thinking one of the big gaps in geological training is sampling. You know, we learn a lot about geology at university and rocks and identification, but there's bugger all on sampling and resource estimation. And when you get into the industry, you soon realise that the results of sampling are where you make all your important decisions and where you go next. And some of those can be very expensive and costly economic decisions. And if the sampling isn't right, you waste your money. Two ways. One is you get a lot of false positives, which you then go and race off and spend a lot of money. And this is mainly directed at the exploration geos. Mm-hmm. And that's a real problem because they've only got so much time and budget to cover a certain amount of ground. And if they're chasing a lot of false positives, they're wasting their money. And then when we get to the resource estimation stage, the whole financial model that pops out the end of that is ultimately based on the quality and accuracy of those samples that are using to support it. So if they're biased in any manner, it's a real problem because, you know, if they're biased low, nobody complains because you're actually making more money than you planned, and you'll never hear a complaint.
Yeah.
But the other way becomes very critical. And, you know, a 5% bias on a multi-billion-dollar project is often half or a third of the ultimate NPV value. So it's really critical at that stage that the sampling is well understood and done correctly by those people who've probably got the least training in it.
Yeah, no, you're right. I always felt that after uni that it was assaying, QA/QC, sampling and resource estimation that were not taught much at university, or at all in some cases.
Yeah.
So what sort of sparked your interest in really diving deep into sampling? Was it anything particular in one of your previous positions, whether a mine position or a position as a resource geologist?
Yeah, well, your very brief summary of my 40 years in the industry there kind of missed out. I had, prior to Anaconda, about 10 years in gold.
Right.
And sampling in gold is a challenge, as you know, because gold density of 19 tonnes per cubic metre tends to settle to the bottom of any powdered thing. So I was working in a gold mine in the goldfields, Mount Morgans, which some people might know, and we had a situation where we were having to bring in ore from a remote site, and they were using blast hole sampling on gold, and the grade control maps just made no sense to me. They were these little sort of patchwork zebra pods of gold we would bring in to the mill versus gold that we'd dump on the heap leach. So I started reading technical papers on sampling and discovered things like Guy's theory and Petard's book and those sorts of things, and started, I did geology, so I didn't have to do math. Like most of us, but started thinking, well, this is only algebra, it can't be that tough, and started looking into it. But what I found was that the advice was the interesting part. So to cut the long story short, we were bringing in maybe half-kilo samples from the blast holes to assay them. And I thought, what would happen if we did 20-kilo samples? And there was a lot of raised eyebrows, but we started bringing some of those things, bigger samples, coarse gold. Suddenly the grade control map started making geological sense. So that really sparked my interest that sampling was really important, to get answers again for those financial decisions.
Right. So you've obviously come into sampling from a gold background, and but in your CV you've worked for a lot of base metals companies. So people would say, well, surely sampling practice and theory is only really important for gold. I mean, how does it apply to other commodities like nickel, iron ore, lithium, or whatever?
Yeah. Well, I think it applies to all products as far as I know, and the big reason there, and I've put a few things out on the internet about this, is most of the things we desire to get in our products, be it gold or base metals, are dense materials, and soon as you create a particulate lot of that material, these things are going to want to move under gravity. Now, again, I was thinking yesterday, I was looking at a project a couple of weeks ago where there's RC drilling. Now, RC drilling is a very good technique. It's quick, it takes a big sample, but you always have this problem of the dust losses. And you've got to understand that it's very unlikely what's lost in the dust has the same density as what's retained in the other material. And so even a 10% loss, in most RC programs, people think, 10% is acceptable. If half of the critical material that was in that 10% lost is retained and the other half is lost, that equates to possibly a 3 to 5% upgrade of what you retain, and then that goes into your resource estimate. So it's not just a gold issue. And then again, in base metals, the golden standard is to take drilled core where there's no loss, hopefully. But that doesn't solve the problem of what happens when it goes into the lab, turned into a particulate lot, pulverized, split, agitated, and then there's the other, back end of that is the chemical analysis, which I can go into more as well. But it's important in everything.
Yeah,
mainly due to density.
Yeah, density, right?
Yeah.
Oh, that's good. So, let's sort of simplify our geological environment into, say, exploration geos and mine geos. Where can the geologist make the most difference with, say, sampling? Let's think about exploration geos. I mean, what do they need to focus on to add that extra value, or to avoid destroying value, as you say?
Yeah, well, it's a conundrum, because most sampling results an exploration geologist is going to get is a null result. There's nothing here. So to some extent, exploration geologists need to sample in a manner that biases the sample to try and extract out some signal that something there. So the classic is, stream sediment samples, where you actually go and concentrate the material to get a biased sample to show that something's there. And one of the first jobs I did in the industry was diamond exploration, where I just spent weeks on riverbanks in the Northern Territory with crocodiles, jigging samples, trying to find not necessarily a diamond, but the indicator minerals that lead to a diamond. So direct concentration, and some of the new techniques like ultrafine clay sampling is a biased sampling technique. So in the exploration stage, it's more about understanding what you're trying to concentrate into your sample, so you can get some signal other than there's nothing here, rather than resource estimation stage, where you're actually trying to get some precision and accuracy.
Yeah, so coming on to that, if you're a mine geologist or a resource geo, I mean, then obviously what you've just been talking about from exploration is totally the opposite.
Yes.
And you need to make sure that the sampling is representative. And what are the key principles there that you're focusing on as I say, a mine geo and grade control?
Well, representativity, which is an interesting word. It's in the JAW code as representativity, but I don't think that's right.
I think it's representativity.
Right. Yeah. Okay. Well, if something's representative, it has representativity. So, but we can argue semantics. The thing is, you're going to make an economic decision. Is this block of ore waste, or is it something we can process to get value out of. So obviously accuracy is critical. So, but you can never get perfect accuracy, as you know. So that is wrapped around the idea that it's the right grade within this bandwidth of error that I'm happy to accept, which is precision. So I think you'll find there's this idea of what is precision in terms of your purpose. So in grade control, the precision needs to be close enough to the cutoff grade that you want, that you're not always sending too much waste to the mill or too much ore to the waste dump. So the key issues there are, I've already discussed, is what are you losing? So if you're using RC grade control, do you really know what that is? I mean, one of the first jobs I had in gold, I had two ore deposits that are about 5 kilometres apart. One was a pyritic gold-rich shale, and the other one was a hydrothermal chert, both pyritic, both containing the gold. And there were two separate problems there. The chert was hard as hell, so when they RC drilled it, huge plumes of dust, up to 15% loss, upgrading the pyrite into the sample. That one was not a good sample. Then the other deposit was pyritic shales, wet ground, not enough air to keep the water out, and all the shale particles washing out and upgrading the pyrite. So both these deposits, I knew they were biased, but then you've got to try and quantify how to deal with that. So the key issues are things like in RC drilling, you must keep the water out, unless you're sampling in a manner that also samples the slurry. So maybe I can talk about that a bit more, but I'll go on for hours.
Yeah. So what you're saying is, and it's worth noting, is that if you're an exploration geo, you have a particular objective, which is to maximise the anomalies. Whereas if you're a mine geo or a resource geo, you want to make sure that you have those accuracy and precision because you're quantifying what it is.
Yeah, very much so. So, and it's a hard thing to do. I mean, in the iron ore industry, they rely a lot on blast hole sampling. So, well, I don't know if they still do. I think that a lot of them are going to these downhole probes now. But that's a challenge because you've basically got this tons of material that you can't access all of. And, the golden rule for any sampling where you're actually making an economic decision rather than trying to find some signal is that every fragment or particle in that lot of material has an equal chance of ending up in the sample. And that's the golden rule I always follow when I look at a sampling exercise. Is this material here, does every piece have a chance of ending up in my sample? And if it isn't, you've got to worry about the bias. So, core is not a problem, but we still cut the core in half.
Yeah.
And we get different answers from both sides. So, this all needs to get measured into your thinking about what you're doing with your sampling.
So as a sort of to wrap up this first podcast, if you're a geologist and let's say you're a recent graduate, and as you've said, sampling is part of your job. What could you do as a young geologist to develop that knowledge? What are the sort of avenues that you can go down?
Well, there's industry courses which are good because they just alert you to different experiences in different environments. I like books,
right,
and papers.
Yep.
But some of these are very esoteric and very hard to read. So I think have a look on the internet. There's a lot of information. I run a group on LinkedIn, Theory of Sampling, and it's just got a lot of stuff dumped in there and examples of different sampling problems and why they're good and why they're bad. So there's lots of knowledge there. And the other thing is do experiments. So I once had a mine geologist who wanted to make his own standards at this gold mine. So I told him to go and get 200 kilos of rock chips and blast holes, and he put them in a cement mixer and he mixed them up and he tried to make his standards, and guess what? They had this huge variability. He learnt a lot. Cost me a couple of $100, but I think people are actually doing their own experiments. So again, if you've got an RC rig that's blowing a lot of dust, collect some of that dust and see what's actually in there. If you've got splitters that you don't think are right, take more than one split, or even split down the whole pile and find out what's there. It's the Pepsi challenge, as I say, and usually for a few $100 you can learn a lot about what your sampling is really telling you.
Thanks, Mark.
Okay.
So that's the first of three. In this one, we talked about the fundamentals, Mark's view on sampling, how to develop your skills as sampling. In the second and third episodes, we'll dive into a little bit more detail into exploration and mine geology sampling. And then in the third podcast, we'll talk about sampling at the processing plant. So thank you, Mark, for that one.
Thank you.
If you enjoyed that, please subscribe to our podcast. They'll be found wherever all good podcasts are found. Thank you very much.